All right. Hello and welcome. We are ready for the next session at this great Datanova event. I have some experts with me here from the Trino and Starburst teams, and we are talking about unlocking your data lakehouse for Trino today. My name is Manfred Moser. You might have seen me on Trino Summit, Trino Community Broadcast, and other things. I help the community and Starburst all around with all things open source and Trino. With me today is David Phillips, who is co-creator of Trino since forever ago, way back in the day, over a decade ago. And he's also, and this is critical, an expert in the open source object storage ecosystem and the lead for our file system refactoring. We'll talk about that very shortly. Next up, we have Karl Steinbach joining us. He's a PM for all the object storage connectors and has a long history in the big data world, knows everything about Hadoop and Hive, probably more than you want to know about at this stage, because as we'll talk soon, this is legacy. And he's also an expert at Starburst. And then last but not least, definitely not least, Alex Sander-Joe. He is joining us as an engineer from Starburst, and he's very much an expert on streaming, Apache Iceberg, Metastores, and much more. And all of us are very opinionated, and we'll have a great fun session today chatting about. It's great to have you all with me. So let's go. What about our first question? So I was thinking, since we're starting with the history, like from way back when with Trino, started with Hive and Hadoop, David, can you maybe tell us a bit about what's going on with our de-Hadooping effort and the file system support, and where we're at with this?
Yeah, so a few years ago, we started a project to de-Hadoop Trino. So Trino was originally written to use the Hadoop file system and like the Hive and Iceberg and Delta Lake connectors, and all the file system access went through that. We also used mostly the Hive readers for things. We ended up like writing our own Orca reader and Parquet reader, but we still had a bunch of Hive code that would actually end up reading things like CSV files or JSON, and they went through the Hadoop interface. But the problem is the Hadoop interface is just like really old and caused a lot of problems for Trino around like class loaders and configuration and just all sorts of other problems. So we needed like a new modern interface that fits with the way Trino thinks. So we had to convert like hundreds of call sites that used Hadoop. We had to write completely new readers and writers for all the file formats. And that was a multi-year project with many people involved, and it's finally done. And one of the very recent Trino releases, we actually made the native file systems enabled by default, and Hadoop is disabled. So now if you want to use Hadoop to talk to HDFS or use the legacy file systems, you have to explicitly turn that on. So we're kind of guiding people to have the right configuration out of the box.
That's awesome. So what were some of the motivations and what are the benefits that we get out of that? Maybe Alex or Karl can also chime in. I think it has to do with dynamic catalogs and memory, but you tell me.
I'll let Alex take
this one. Yeah, go ahead, Alex.
Yeah, I mean, for one thing, the code is just a whole lot simpler. I think we've removed an absolute ton of code that used to sort of mesh the old Hadoop dependencies in with Trino, and it just well, selfishly, it reads a whole lot simpler now. So fixing bugs and making improvements is a whole lot easier. But it also gives us direct access to the clients that we use to read data out of the object stores. So S3 is a great example. They've been adding a bunch of new features recently that are really designed for like lakehouse architectures. And with the old Hadoop system, we would have needed to wait for them to plumb all those features through in a way that was accessible to us. But now, as soon as they're available in S3, we can hop right in and use them immediately. So that's given us a lot better power to use these things that the cloud providers are providing as lakes get more popular. And S3 is realizing that, or AWS is realizing that S3 was missing some crucial building blocks that we needed.
Yeah, the abstraction are a bit different, right? Like HDFS was very different from what we have now with the cloud providers. Karl, can you tell us what happened back in the day on Hadoop days?
Yeah, I mean, there's I think it's a classic example of a project just becoming popular before it was really ready. There were a lot of half-baked sort of APIs in Hadoop, which I think had been written just in terms of like, let's get this done. We need to make progress. But designing APIs is a subtle art, and it's only after you've burned yourself a couple of times and built up a lot of scar tissue that you start to understand all the implications. Hadoop was, of course, stuck with the Hadoop file system API, which was designed really to work both like on the server side on data nodes, but also as a public client API. So there was some weird stuff going on there. And then, if you want the whole historical context, there was an aborted attempt to replace it with something I believe was called FS context. Much nicer API, but at some point, the people running the project realized that the older API, even though it was worse, was so deeply ingrained everywhere by that point that a migration to FS context just wasn't going to happen, and aborted that. It reminds me of I don't know if HDFS supports symlinks yet, but there were like 5 or 6 aborted attempts to implement symlinks in HDFS, which ran into sort of similar issues, legacy concerns, different stuff. One of the longest Jira tickets I've ever seen. It went to like 100 pages, I think, of comments back and forth.
Yeah, it's much more oriented around file system reads on like actual file system versus the typical in the cloud via HTTP kind of stuff now, right?
Yeah.
Yeah, it's a great point. The Trino file system APIs actually have specific contracts. They're much simpler because the Hadoop API has like over 100 methods in it, and we only need like maybe a dozen. And so the Trino ones are designed for exactly what Trino needs, and they have very well-defined semantics. Whereas like the Hadoop ones were written 15 years ago or 20 years ago, probably at this point, for HDFS. And it's like, okay, well, how does that apply to S3, right? Because like the guarantees that you get on S3 versus HDFS are completely different. You end up just having to like go dig through the code for every implementation to try to figure out like exactly how this method call is going to behave. And so with Trino, you can just go read the file system spec and we know exactly what the method is going to do and how it's going to work on all the different implementations.
That's cool. Yeah, time has definitely moved on, right? Carl, we moved beyond Hive as well. And like, in the last couple of years, Iceberg emerged and Delta Lake emerged, and then a whole bunch of like events happened in the last couple of months. Do you want to give us a little bit of a rundown, sort of like what are some of the big things that happened recently at various conferences and from various vendors, and where do we stand with Trino on that side?
Okay, that's sounds like a
big question, I know.
And also preface this by saying I haven't been attending conferences recently, so I'm not fully up to date with what's been going on there. But I think that just in the last year, there's been a tremendous amount of excitement, both in table formats, but I think also in Iceberg in particular. And it seems like a lot of industry players, probably with the exception really of Databricks, have decided to move in that direction. And I think that's both a recognition of the fact that Iceberg technically I think is the best choice, but also in terms of the community around Iceberg and the way that project is managed. I think vendors have a lot of confidence that they're not going to find themselves at a disadvantage relative to the people running the project. And similarly, customers look at that and they realize, like, if we're going to migrate all of our data over to a new format, we don't want to get locked in to some sort of abusive relationship, with the group that controls the project. So yeah, I think at this point, Starburst is all in on Iceberg. You see a bunch of other companies have also declared that Iceberg is the path forward for them. And I think that there's a lot of excitement in the project itself among the core contributors in terms of what will be added. And also, I think for Trino, this represents a really interesting opportunity because historically, Trino has sort of been at the whim of like other table formats, right? Like we've been stuck with the Hive's table format for such a long time, even though we know that it's broken in a bunch of different ways and that it leaves a lot of opportunity for optimization on the floor. And Iceberg, really was designed as in part a reaction against Hive's table format. It's like we know what the problems are. Now we're going to go and fix it. And in a way, I mean, you also have to give the people who built Hive credit for, I think, coming up with a lot of really good ideas. But they couldn't fix everything at once, right? Sometimes you have to create a problem in order to fully appreciate it and then come up with a better solution along the way. So Dan and Ryan certainly deserve a tremendous amount of credit for designing Iceberg, but I think we also have to acknowledge that they were, Iceberg is as good as it is because other people helped us discover what the problems were that we needed to go and fix.
Yeah, it's interesting also because obviously, I mean, that's not obvious, but like some people might know, Iceberg emerged out of Netflix, and it emerged out of Netflix together with Trino. So Trino has always been a sort of first-class citizen and like very much be in line with the Iceberg usage, which is great because it helped with the development of the spec and found issues where, you know, different query engines just operate differently. And Trino has always been on the forefront with Iceberg. At the same time, and that's also been very interesting, we also have very, very good support for Delta Lake these recently, right? So Alex, you know, right, like there's been a lot of change going on in there as well. And we had presentations recently at Trino Fest and so on about Delta Lake. So both of those choices are available and like very good, very well supported by Trino. And I think that's good, right? Like people ultimately want optionality, even if there is one that's clearly better. In the end, everyone just should get off Hive, right?
Yeah, that's the first priority, certainly. And I also think that you know, there are a lot of smart people working on both Delta and Iceberg. The two communities overlap quite a bit now in terms of contributors, and certainly after the Tabular acquisition, you know, I think most people expect that Databricks is going to start to invest more in Iceberg. But you know, I've often said before that given enough like time and money, both projects are going to end up in the same place. I don't think there's any real disagreement about fundamental technical approach or about the features that a table format should provide. I think there's also a lot of agreement that fundamentally a table format is an implementation detail that customers really shouldn't need to worry about. And I think if you look at some of the recent announcements from Snowflake and Databricks with respect to their catalogs, they're really trying to say, let's move the conversation away from table formats and over to catalogs, which is an interesting change.
Yeah, fair enough. David, do you want to tell us a bit about the role a catalog fulfills compared to like, you mind, there's the object storage, which is just files. Then there's the table format where we have Iceberg, Delta Lake, and the old Hive format. But now there's this catalog. What does that do compared to like the query engine? Like why do we even need a catalog?
Yeah, well, it's actually, this kind of melds with the previous topic that if you think about where these systems came from, so like Hive came out of Facebook in the early days when they were trying to scale. They were collecting all this log data on Hadoop, and they were writing MapReduce jobs by hand to do analysis like how many users are visiting the site each day. And then they decided, well, you know, we really need something better than this. So they created Hive, which was like a kind of thin SQL-ish layer on top so that, you know, they didn't have to write MapReduce jobs by hand. And then that just kind of grew and evolved organically. Originally, they were just collecting files in kind of like a CSV-ish format on Hadoop. And then with Hive, they decided, well, we don't just want to store files in the file system. We actually need like a metastore to hold metadata about like the tables and the partitions, and then later on statistics. And so the metastore API grew and evolved over the Hive days, and it ended up like the metastore API itself like gained like over 100 different methods. Like it's an extremely complicated API. It ended up getting even more complicated with Hive Acid, which hope nobody has to deal with that anymore. But then Iceberg came along and said, you know what, like the metastore is way too complicated. Like, and actually it was a big bottleneck on query processing, because when you're trying to plan the query, you've got to go to the metastore, make a whole bunch of APIs. The metastore is often slow and bogged down because it's very heavy with like a backend database. So Iceberg instead stored all the metadata and files on the file system, and very well optimized files that were easy to query during planning time. And they said, and so the catalog or metastore implementation for Iceberg really only needs like list tables and give me the current metadata file for this table. And so like they completely went like the opposite way of Hive. So like it's like basically the minimum possible thing that you could need. But now people are kind of realizing that actually you kind of want a little more metadata in your catalog, and actually like you can keep other stuff like management information or partitions or like things to like help you operate. And so they're kind of going and adding a little more stuff to the catalog interface, but hopefully it won't become as complicated as the Hive Metastore.
So what are some of those prevalent like Metastore catalog projects now that are going on that are widely used, Alex? Like obviously it's the Hive Metastore, which is like Thrift protocol, server, and then database that's often undersized, as David says. And then there's the AWS Glue, but there's some new contenders now. Tell us a bit more about them, maybe.
Yeah, I think the main reason to pick Iceberg over, say, Delta these days is that it's readable and writable from so many different engines, whether it be Spark or Trino or Snowflake now, and a half dozen other vendors that are supporting Iceberg. But once you get into the weeds, you realize that actually not all of these vendors support every catalog. So if you're going to use Azure, for example, you're not going to be using Glue on AWS, and so the compatibility matrix of engines to catalogs is not quite complete. So if you want to be able to read from 3 different engines, you need to pick a catalog that is supported by those 3. But I do think that the community as a whole is sort of settling on the REST catalog as being the de facto one that if you're going to write an Iceberg integration, you at least at a minimum need to be able to support REST. And I think that's why we're seeing a lot of press around Polaris, especially after Tabular got acquired by Databricks, because it is hopefully going to be the de facto REST catalog that any Iceberg reader and writer across the dozens or so that exist will support that one at a bare minimum. And now there are some cool features that are going into the REST catalog specifically because, like David was saying, it can be a little bit smarter and it can do some caching or planning work for you that sort of ups the complexity a little bit. And so I think it's a really good place for the community to be landing, where the REST catalog is becoming the de facto, and it is becoming just smart enough to be useful.
And I think
so you mentioned REST. Sorry, you mentioned REST catalog and you mentioned Apache Polaris. Carl, can you maybe explain how they are related? Because it's not the same thing, really, is it?
Sure.
No,
yeah.
I think that's an interesting thing to sort of dig into. And just to make sure listeners are keeping up, like, it's important to emphasize that when we say REST catalog, we're not talking about just a metastore that has a REST API. We're talking about, we're using that as a shorthand to say that the Apache Iceberg project defines this standard REST API that Iceberg REST catalog services can support. And once this was defined, a bunch of people in different projects went out and implemented it. And Alex, was talking about how the matrix is a little complicated right now in terms of which catalogs can run on which cloud providers and things like that. But I think for prospective users, the nice thing to know is that if you build a system that knows how to talk to an Iceberg REST catalog, you're probably going to be able to find one that's supported on the platform that you're using. And it's also, I think, really nice to see these different projects like agreeing on an API. As David was saying earlier, fundamentally, like the API for a REST catalog does not need to be that complicated. It's like, give me the mapping from a table name to the Iceberg snapshot that it currently points to. The fundamentally most important thing that it does is provide that atomic pointer update so that when you get ready to commit a change to an Iceberg table, it atomically bumps that pointer and makes it visible to everyone at the same time. Everything else on top of that is just sort of like gravy. But I think also, like, the Hive Metastore has been around now for 15 years, and looking at that, like, it provides a pretty good standard of, like, these are the sorts of things, roughly speaking, that a standalone catalog service should provide. Yeah.
Mm-hmm.
What more can I say?
Good clarification, Carl. Thank you.
Yeah, so it's a spec and an implementation. Polaris SDM is one implementation. I know that, like, a friend in the Trino community, Kevin Liu, actually hacked one together in Python easily, but there's also more solid ones, right? Like, I believe that the Unity catalog from Databricks also aims to implement that feature at some stage. Now, my question goes like the reverse. That's not good enough, though. Like, Hive doesn't support that catalog, but I don't want to run a HMS and or and an Iceberg REST catalog kind of implementation. So what do you see as the future that helps people get off Hive and into a modern format, whatever catalog? Like what's going to happen there? And then also related to that, you say it's very simple, but at the same time, all these like new projects talk about security and governance and everything. So like maybe it's not that simple. So give us a bit of a view on what you think is going to happen there, Carl. And then maybe David and Alex can also chime in after.
Well, you're absolutely right. It is more complicated than I said. I mean, I was thinking about it just from sort of a core engineering fashion, but you're right. Like all of this other stuff, like security, is very, very complicated, especially with all the different standards that you could potentially have to support. I think another trend that I expect to see is that both Iceberg and Delta, right, require maintenance. As you add information to an Iceberg or Delta table, it creates garbage or files that you need to compact. And it makes sense, right, that if the catalog service is basically your point of control for doing these atomic updates, and the catalog service hence knows when a change is being made to an Iceberg table, it's the logical control plane through which to build data maintenance tasks, that need to kick off, in response to a table being modified. So I think we're going to see that a lot more. If you look at Glue, for example, Glue is basically a data management and data maintenance layer built on top of a catalog service. I expect that Polaris might move in the same direction. And also, just going back to what you were saying earlier about projects, like I feel like every week I hear about a new catalog service, open source catalog service that supports the Iceberg REST API. Just the other day, someone pointed me towards a project on GitHub that has implemented it in Rust. Rust people seem to really like implementing things like that. So but it's exciting to see. So yeah, Alex, David, how about you jump in and offer your take on this?
Yeah, I think you're totally right, and in that the maintenance is sort of the next big thing we're going to see coming in the next year or two. Like I think the catalog largely is a way to get customers with one foot in the door and into an ecosystem. And what we're going to see next, I think, is once you have that foot in the door with whatever catalog you want, having it be really easy to say, well, you could just pay us a little bit more money and we'll do all of this maintenance for you. I know we have a feature, I think, in public preview right now, where if you're using our Galaxy product, you can go in and you can click a button and we'll do all of our maintenance for you. If you are using AWS Glue, for example, I know they have a button in preview where they'll go and do maintenance for you. And so I think what we're going to see with Iceberg over the next year is how managed of a solution do you want? Do you want to go all in on, a catalog and their maintenance and just have tables and forget about it? Or do you want to be in the weeds and do the nitty gritty and work on maintenance yourself and really fine tune and optimize every single little operation? The great thing is that Iceberg gives you the option of doing both. And if you're running SQL queries, obviously you should be using Trino regardless of which of those options you use. Yeah, I think that's going to be the next stage that we'll see in the next year or two is management and maintenance.
So let me be devil's advocate here for a second. So David, you come from a query engine background. I was the creator of Trino, and we have lots of functions in Trino in the Iceberg connector that does compaction and registering tables and working on metadata. Why should we give that management off from the query engine and let a catalog do it? Couldn't the catalog just stay dumb and the Trino engine can take care of all that?
Yeah, so the catalog can actually do background maintenance that Trino is not really set up to do. So Trino has commands to optimize a table. So after you write some data, you can manually run a command to optimize. But when you've got hundreds or thousands of tables and thousands of jobs running every day, right? You don't want to have to manually or go script a bunch of stuff to run all these jobs. Having the catalog do it just makes it a lot easier.
So there's that balance. So ultimately then there's going to be a bit of a like tricky situation, right? Like where you have to really decide what catalog you're going with. And like also like Carl, when are you going to throw away Hive Metastore then?
Unfortunately, I think the Hive Metastore is going to have a very long tail. I'm not talking specifically about our customers, but I think just the ecosystem in general. I remember like when I worked on Hive 10, 15 years ago, I always felt that the Metastore was like the most valuable component of Hive, which is not to say that the rest of it wasn't great. Like I think a lot of good ideas there, but the Metastore was really unique because it was the first time I was aware of someone having this idea of taking the catalog service out of a database. You know, Hive was really the first example where people took this monolithic stack and started to deconstruct it. And if you look at like the last 15 years of big data, really it's been about moving from sort of this modern era of monolithic databases into this postmodern era of stratification, or maybe not stratification, but pulling things out and providing optionality at every layer of the stack. And to me, like someone who's really into abstraction and indirection and leverage, like those are my three favorite things about computer science. Like this has been a really exciting thing to watch happen.
Yeah, it's also funny to watch though. Like ultimately, we did all these things, pull things apart, and we broke every one of them. We broke ACID, we broke like everything was actually broken, and now we're slowly putting the puzzle back together to get all the features we already had in those nice relational databases, right? So it's also kind of entertaining, but obviously at a completely different scale. So that's also very interesting.
So the Metastores.
Sorry, go ahead.
I said the Metastores have really allowed Trino to exist. Right, like if all the data had been locked in some kind of like proprietary hidden format, like we wouldn't have been able to write these new query engines that were able to access the existing data. Now, I wouldn't say the Metastore was really like designed to be open to other query engines. Like all the way it stores things are like very Hive specific. Like it stores Java class names for like Hive classes for like reading and writing data, right? So you kind of have to like it's very messy, and like actually in the beginning like took lots of kind of like reverse engineering to make it work. But the fact that it was there and it was an external API that you could call to figure out like, where's all the data for these tables? Like that's what let us create Trino in the first place.
Mm-hmm. And so now Trino is on the way to become sort of like the dominant query engine, like Postgres is the dominant relational database, right? That's our hope anyway. So we're working hard on that. And I think Trino is in a good position because we have this plugin system of lots that supports lots of different connectors. We already work very well with like all the table formats. Essentially, we work well with Hive. I mean, that's been like from the start. Great Iceberg, Delta Lake support and stuff. So I think that's very exciting. So if Trino is becoming sort of this dominant query engine, as we hope, people will still want to use other query engines. So how do you see this kind of world of multi-query engine panning out for users, right? Like what's some of the exciting things that you think will happen there? Maybe David, you talk about some of the nitty-gritty details.
Yeah, I mean, well, we'd like Trino to be useful for everybody, right? For like the majority of your workloads, like use Trino, but you can definitely think of some interesting stuff you can do with like allowing data to be used by other like tools or engines. Like for example, like maybe you want to store like time series data and use more like specific like time series tools to query it and visualize it that that are easier to do in a different tool. So like I always like to tell people, you know, use the best tool for the job, right? Like, you know, I love Trino, working on it for like past 12 years, right? But like if there's a better tool, like go and use it. You know, I'm not going to tell you to go and use Trino just because, you know, because I like Trino. I want people to get their job done. That's why we wrote it.
Yeah, that's also good because you go, Carl.
I think that's also part of why we're excited about Iceberg, because Iceberg helps to facilitate that optionality. So if for some use case you do have a better tool to use, or you feel, I mean, a lot of times we'll see customers, right, who it's less about technology, maybe just more about the structure of the organization they work in, right? There's another team with another engine that they use, and it's just, you know, impossible to say everyone should use Trino. But I think, you know, Trino from the very beginning, part of the philosophy has been to play well with others. And Iceberg is definitely now like, you know, definitely going to help us further accomplish that mission.
Yeah, like
Yeah, sounds like you got it.
Yeah, like we prototype building a tool to store application tracing data in like the application performance monitoring space. So you collect traces from your applications and you store that in Iceberg. And when you're using tracing at like large scale applications like Trino, you could like generate millions or billions of events. So you really need like a scalable data store like Iceberg to store them. Now, the cool thing is now it's an Iceberg. You can just go use Trino. You can run SQL on top of it, do all kinds of like fancy analysis. But like for your day-to-day usage of it, like, you really want to use like a tool that's designed for like visualizing traces, gives you a nice UI, right? So you can see where like you want to do some ad hoc like deep analysis, go use Trino with like full SQL. If you want to just do like day-to-day like visualization, use a tool designed for that. But because you store it in Iceberg in this common format, you can use whatever tool works best for the task you're trying to do.
I think
Fair
that's
enough.
a great point, and why I see Trino being a part of maybe not every Iceberg installation, but at least most Iceberg installations. It's like if you have a very niche tool that does something very specific, that's great. But almost everybody wants the option of being able to do ad hoc queries. I've seen that in past jobs that had like very specific sort of cube rollups that were like very catered to, very specific dashboards. But as soon as somebody wanted something that wasn't exactly what we catered those to, it was impossible. And so having the option to just write a SQL query is invaluable in almost any setup.
We saw that all the time inside of Facebook as well. Like teams would have these basically custom data stores and then write these were effectively very custom query engines on top. And like those worked great until they wanted to do something else. And now it's like, well, go spend a month like adding this feature to query engine or hook it up to Trino and just like run a SQL query on it.
So we are settling into a multi-engine world. What complexity does it bring? Like I'm thinking of like things like Iceberg views recently came up with feature, and then the viewer has to declare that it's the dialect of engine X versus Y, or also like data types and stuff like that. Can you tell us a bit more about like some recent developments there and like maybe what's exciting about that, Alex?
Sure. Yeah. I think the big two that I'm keeping an eye on in the Iceberg world are the view and materialized view specs. We've had materialized views in Trino on Iceberg for a long time, but unfortunately, it's one of those things that we've sort of custom built on top, and so they're not really usable if you have a Spark cluster, for example. Your Trino views aren't going to work in Spark, and so the Iceberg community moving towards formalizing some of those definitions in a way that they are truly cross-engine is a huge step in the right direction as far as making all features in the table format actually cross-engine, not just the data storage itself. So yeah, I think the developments there are a huge step in the right direction.
Sounds like it's going to get pretty complicated.
Yeah, unfortunately, we do then get into some complexities of like, which variant of SQL do you happen to write this view in? Like, Trino supports ANSI SQL, which you would hope would be the standard across the board. But I think we see time and time again that it's not as standard of a standard as we would like. So there will be some complexities there to work through, but it's good problems to have.
So with these like kind of like views and materialized view support coming, that's obviously something that like many enterprises wish for. Another thing I think that lots of people are clamoring for, I want to understand better, is what about like sort of like everyone's like the future is about AI. What about like things like in like these kind of use cases or maybe data types that are associated to it? Do you think that the engines will also like try to go expand into that world one way or another? Or what are some of the trends you see or hear about people using Iceberg, Delta Lake, and Trino for this kind of stuff? Whoever.
I'll say I think for AI use cases, we're probably first of all going to see more changes at the file format layer. to support vector types and things like that. And I do firmly believe, though, that if you look at a lot of the data management problems that people in the AI space have, I feel like you can look at what databases have done and at least glean a lot of good ideas from databases. I mean, I'm also sort of firmly of the expectation that like eventually we are going to see a lot more sort of like AI type workloads moving into the database, just because it's such a powerful model for managing data. SQL, fundamentally is such a powerful API for querying and manipulating data. I think if you look at things like machine learning and stuff like that, where a lot of it is feature extraction using these sort of like custom UDFs, that's the main sort of like impedance mismatch right now with SQL. And the reason why I think you see a lot of people using Python or Spark for these types of use cases. But I remain optimistic that like fundamentally the model of tables and views are things that I expect people to start applying a lot more for machine learning in particular.
So you mentioned
I'm not an expert in that domain.
No, that's definitely like we had Trino community broadcast episodes about like various AI integrations with Trino. There's definitely lots of things that can be done, and I'm sure will ultimately come down the pipe as well. One thing you mentioned is it's going to be more on the file format layer. So can you just quickly explain what that means, like where we're at with the file format, right? We talked about table formats, Iceberg, Delta Lake, but we didn't even talk about that, David. What's happening on the file formats? You mentioned earlier CSV type of kind files. I'm sure that's not what's you use these days anymore, hopefully. So where we're at with that?
I'd say actually file formats have kind of been trending in the right direction in that we used to have support a whole bunch, like Hive supports like CSV and JSON and text file and 2 variants of RC file and ORC and Parquet and probably some others that I'm forgetting about, right? And the problem with Trino kind of like being in the middle is we have to support everything. Like, and then on top of it, right, we have to support Hive, Iceberg, Delta Lake, and Hoodie table formats, right? And so like you end up like implementing like everything anybody comes up with, they want it in Trino, so we have to end up implementing and supporting all of it. But with actually Iceberg and Delta Lake only supports Parquet. Iceberg supports Parquet and ORC and Avro, but like pretty much people only use it with Parquet. So like the good thing is like, I mean, Parquet and ORC were always competitors, and like there's kind of good and bad about both, but they're very similar, and like more or less it's a good choice either way. And so thankfully it seems like the community standardized on Parquet, and so like in the future we only have to support one thing. So I'd say like at the lower level file format, like things are actually trending in the right direction of like just having one standard that works good enough.
So you're expecting that some of those like new file format sort of like data types might end up emerging in Parquet. So that's a good sort of horse to bet on and like stick with Parquet. Seems like everyone has settled on that to some degree already.
Yeah, I think so. And a good example of this actually is work on a variant type right now for Iceberg and Delta. And it's hard for like 2 table formats to agree on how to manage a type definition. So I think the agreement has been struck that actually Parquet should be responsible for the variant spec. And I think, also related to sort of like AI and ML workloads, one thing you see a lot is unstructured data as well as semi-structured data that needs to be processed. I think one type that I could see Parquet potentially adding, or Iceberg for that matter, is like a blob type, or I know Oracle supports something called bfile, which is actually basically just a pointer to a file on object storage or the local file system. And I think that for sort of like data management tasks where you have maybe 1 million video clips, right, and you want to associate information with them, that's a tabular problem, right? And being able to drive some sort of processing workflow off of streaming that table and delegating the work to workers, to me seems like a really elegant solution to that. And I'll also go back to sort of saying that I think one of the sort of like interesting historical trends, right, was when Hadoop emerged, like it gave us this file system, but what you really wanted was like a data set system or a table system. You didn't need like all of these hierarchical file system management commands. And in fact, that just created a lot of problems. It made HDFS less scalable than it could have been otherwise, because you have this central name node that needs to manage all of the file system information. And the Metastore helped to facilitate that transition from a file system abstraction to an object storage abstraction. But that said, like an object store alone, I don't think is great for, let's say, you have 100 million video clips, right? It's I think having, being able to, in a sense, to have some sort of like hybrid approach where you can still easily like associate metadata with each one of those clips, and not do that using like JSON files riding next to the video clips. Like there are a lot of performance advantages as well as I think just data management advantages to that approach.
Yeah, that's definitely interesting. I think like the variety of like data types in terms of like, especially like you're saying audio, video and stuff, that's just going to explode, right? It's already massive at some place, but it's probably going to become more common for like everyday users and like everyday companies that use these platforms. So very cool. So let's round out a little bit. So David, what gets you excited these days about like query engines, catalogs, object storage, and like, all these different systems? What do you see yourself working on in the next whatever months that you think is gonna like be super interesting and fun for our users to explore and play with next?
That's a good question. I like that there's a lot of innovation happening in this space, because I think like for a while, like maybe in the kind of the end of the last decade, things had kind of like stagnated. And so like with Iceberg in the catalog space, like really in the past few years, there's kind of been like a renaissance of like, ooh, let's try to like add more stuff and drag this forward, as opposed to like, well, we're just kind of stuck with Hive and the Hive Metastore. Like we're seeing a lot of innovation around like statistics or data layouts that can make queries go a lot faster. Like the Z ordering or the liquid clustering stuff is actually really cool, because it frees people from like static partitioning and like thinking about how to lay out the data. It just does it automatically. Like I've always been a huge fan of like just have the database do something automatically for users whenever you can, because like it's hard, like even for experts, it's like it takes a lot of time to figure out like how to optimize stuff. Like for most people, they just don't have the time or the expertise. So if the system can just do it automatically, then that's great. And so I think like that, plus like the background data maintenance tasks, like we're just making things like faster and easier for users.
Yeah, I always enjoy that. It's like writing SQL text versus some procedural thing. You just tell the engine, get me the data, and that's it, right? Rather than like, how do I do that? Whatever, I don't care. You give it to me. So what about you, Alex? You're obviously diving more into the Iceberg ecosystem, I think, and like involved in streaming ingest and stuff like that. What's exciting for you these days?
Yeah, the streaming ingest project has been huge for the last couple of months. For me personally, I've been focusing more on within that project, making sure that customers that use it don't need to worry about any of the maintenance or processes that you would want to run in the background to make sure that your tables are always spick and span and ready to go. With streaming ingest, we do all of that stuff behind the scenes. So regardless of your data volume, it's always in a format that is compact and ready to go. So that's what I've been working on for the last couple months. I'm hoping that we're going to be able to bring that type of ease of use and that type of set it and forget it mentality to more of our Galaxy customers. I think that's going to be the major focus of the next couple months to a year.
Yeah, that's awesome. Carl, what about you? Last but not least, you're talking to customers a lot as product manager, obviously, and they probably tell you about, well, you support Polaris and like you still have to have HMS and Glue and whatever. Like we need all these things, and like Polaris is also exciting. What are you gonna do? So what you see happening there, and how is it gonna be exciting for you to help our customers?
Well, I think one major focus for us over the next year is going to be providing customers with a really smooth migration route off of the Hive Metastore and the Hive table format and over to Iceberg. And that will be a particular focus. But I'd also like to just say that I think David was spot on in talking about how Iceberg really opens the door to doing a lot of interesting optimizations, both in terms of the query engine, but also in terms of data layout optimizations. And with Hive and Hive table format, really, like in theory, maybe some of these things were possible, but Hive, it was like building on quicksand in many ways, like so much. So, there was no spec, right, for a lot of this stuff. So you couldn't tell whether these things were intentional or just unintentional. Would they change in the future? Like, I think trying to build stuff like this on Hive would just turn you into a very paranoid person. And if you look at the way Iceberg has been built from day one, much like Trino, it's built by people with genuine experience and people who I think have invested the time to build projects that are going to be here for the long term. So part of that is making sure that projects have a specification, right? That the specification is open and that there's a well-defined process for how the specification evolves over time. I've been very impressed with the Iceberg community, the way they vote on specification changes, the way they're very deliberate about introducing these things, and the level of scrutiny that community members apply to changes. And while that does make things take longer, it also yields a much better end result.
That's awesome. Yeah, no, exciting times ahead. I'm looking forward to all the innovation. And of course, Trino is going to lead the way and bring others along. And it's going to be great to collaborate with all these ecosystems and help everyone to use Trino and all these new table formats to get their insights even faster than they ever have before. Thank you so much again for joining me. This has been awesome to talk to you. And I hope you all have more fun at the rest of the conference today.
Right on.
Thanks, man.
Thank you.
Bye.